NASA, we are ready.
Не видит, видит он меня, нет?
Hello, this is John Mather, and we are also ready.
Okay, we'll start.
Дорогие друзья, добрый день, добрый вечер, доброй ночи и доброе утро всем, кто сейчас уютно расположился у экранов своих, у мониторов компьютеров с чашечкой чая и кофе, кто видит и слышит нас благодаря интернету. Мы находимся в одном из залов крупнейшего российского информационного агентства РИА Новости. Это совершенно замечательный зал, потому что он оснащен суперсовременной техникой. И эта техника позволяет нам сегодня быть на прямой связи с НАСА, с США, где уже расположился, тоже вполне уютно, как я вижу, наш гость и наш собеседник, лауреат Нобелевской премии по физике 2006 года, доктор, профессор Джон Мазер. Доброе утро, Джон. Помахал.
Good morning. Good morning.
Morning, Джон. Очень рада видеть вас в добром здравии и в такой великолепной физической форме. Из этого зала будет идти прямая трансляция вашей лекции по интернет, которую смогут увидеть тысячи людей в разных городах и разных уголках нашей необъятной страны. Но прежде чем мы приступим к этой лекции, я должна все-таки сказать несколько обязательных и важных слов. Вот праздник интеллектуального общения, на котором мы сегодня присутствуем и в котором мы будем участвовать, состоялся благодаря усилиям двух организаций – фонда «Династия» и агентства РИА Новости. Я хочу напомнить нашим всем уважаемым зрителям, кто слышит и видит нас, что фонд «Династия», Джон, это вам будет интересно, первый частный благотворительный фонд в России. И этот фонд учредил на свои личные средства Дмитрий Зимин. Это очень известный в России человек, потому что он основал сотовую связь в России и первую компанию «Вымпелком». Главная цель фонда — отыскивать и поддерживать талантливых людей, молодых талантливых людей в науке и образовании. Потому что, так считает Дмитрий Борисович, именно талантливые люди могут изменить нашу жизнь и наш мир к лучшему. Полагаю, что вы вполне разделяете этот тезис. У фонда «Династии» есть обширная программа популяризации науки. Вы в курсе, вы согласно киваете. И в рамках этой программы есть проект «Наука без границ», согласно которому фонд «Династия» привозит в Россию звезд мировой науки для того, чтобы они прочитали публичные лекции. И у нас уже побывали в России Нобелевский лауреат Джеймс Уотсон, у нас побывал Нобелевский лауреат Дэвид Гросс и ваш знаменитый физик Фриман Дайсон и многие другие. Они прочитали блестящие лекции. Сегодня в этой череде ваша лекция. Но она, к сожалению, такая почти виртуальная. Мы не можем вас, Джон, извините, осязать. Мы можем вас только видеть и слышать. Это первая такая лекция вот в таком необычном формате. Будем надеяться, что все технически сработает безупречно, но если вдруг возникнут какие-то проблемы, заранее просим извинить наших уважаемых зрителей. Это наш первый опыт. И, наконец, два слова о второй главной организации, участнике этого события. Это, конечно, российское агентство РИА Новости. РИА Новости в этом году тоже включилась в программу, создала свою программу популяризации науки и просвещения. И 2 июля РИА Новости запустила свой научно-просветительский мультимедийный проект «Мозаика знаний». Вот в рамках этого проекта был создан научно-просветительский клуб лекторий «Мозаика знаний», который приглашает и объединяет людей разных профессий, разного образования, разного возраста. Всех тех, кто разделяет идеи, ценность идеи непрерывного самообразования, кто готов делиться своими знаниями, своим накопленным и переосмысленным опытом. Что еще мне важно сказать? Я бы хотела вам, Джон, представить тех, кто сидит в этом зале. В этом зале сидит ваша группа поддержки. Это журналисты самых разных изданий, это ученые, это сотрудники фонда «Династия» и сотрудники агентства РИА Новости. И позвольте мне представить вам для вдохновения директора фонда «Династия» Анну Петровскую. Анечка. Да, помаши ручкой. Директор фонда, а также директор программ фонда, с которым вы знакомы заочно, Константин Петров. Константин, где вы? Вот теперь вы знаете, как выглядит Константин Петров. И, наконец, я хочу представить вам Альбину Пылаеву, продюсера этого проекта, продюсера проекта «Мозаика знаний» в РИА Новости. Итак, все важные слова сказаны. И теперь я с удовольствием предоставляю слово Нобелевскому лауреату по физике 2006 года, профессору Джону Мазеру. И мы сейчас все вместе с вами послушаем лекцию «От Большого взрыва к орбитальному супертелескопу Джеймса Вебба Space Telescope и новым Нобелевским премиям». Ну а после лекции мы сможем задать Джону Мазеру любые вопросы. Да, вопросы онлайн, вопросы будут из зала, и вопросы будут поступать к нам по интернету. Вы готовы, Джон? Удачи вам!
Yes, we are. Thank you. So, greetings from NASA Goddard Space Flight Center here in Maryland in the United States. This is the largest scientific laboratory for NASA, and this is where I have been working for a long time, since 1976. And now I want to tell you the story of the work that I have been doing for much of this time, and the work of many others. So I want to tell you about the history of the universe. So do you actually see on your screen my view graphs, my computer presentation?
Yes, we see, yeah.
Okay, very good. So I'll try the next slide, see if that turns up correctly. Good. I wanted to show you where I started out my scientific career as a child. This is the spot in New Jersey, which is an experimental farm for the University of Rutgers University in New Jersey. It is a place where my father was studying dairy cows, the production and improvement of milk from dairy cows, and it was also a good place for a young person such as myself to read many books and to look at the sky at night. So one never knows what history will produce. So now I want to tell you what astronomers are busy doing. We have, as astronomers, the task of understanding the entire history of the universe and how it produces the possibility for life here on the Earth. So astronomers start with a picture of the Big Bang as seen from the inside, and I will tell you more about how we measured this. We have ideas about how the first galaxies and stars were made and how they change with time. We have ideas about how stars enable planets to exist, and finally, how they enable the possibility for life to occur. As you see there in the middle of the screen, very many possibilities exist. So astronomers have the easy part. We have to explain the physical part. Eventually, the biologists have to explain the biological part, which is much more difficult. Now, I would like to give you a bit of a surprise here. When one wakes up in the morning to comb one's hair or to prepare to go out for the day, you are already looking at evidence about the beginning of the universe. Because when you look at yourself, you are looking at atoms that did not exist in the Big Bang material, but were produced later by generations of stars which exploded and liberated their material back out into outer space, and it's come back to be reformed and recycled into stars and planets, and we therefore are able to live on the planet Earth because previous stars have exploded and been recycled. So it's a strange and exotic story that we have to tell, but any story that would explain the whole history of the universe would indeed be strange and exotic. Now, the next chart, I will explain a little bit for the general public about how astronomers are able to tell this story. So the first and perhaps most important thing is that astronomers are able to look directly back in time. Light travels extremely rapidly, but its speed is nevertheless not infinity. So we are able to look back in time, small amounts or large amounts, according to how far away we are looking. So if you see the sun, you see it as it was 500 seconds ago, the nearest other star as it was about 4 years ago, or if you were able to look at the most distant things in the universe, you see them as they were about 15,000 million years ago. The current best number is 13.7 thousand million years ago. So we are able to look back in time, unlike all other scientists. Now, geologists do indeed look back at old rocks, and historians look at old documents, but astronomers look at things as they actually were thousands to billions of years ago. Our penalty, our challenge is that the images that we get are fuzzy and faint and require a lot of calculation and thought, but nevertheless we do indeed see things as they were when light was sent out billions of years ago. So the next question that the public would have is, well, how far back are you looking in time? So we have, of course, just to measure distances. So we measure distances in the same way that the ancient Greek astronomers and ancient Egyptian astronomers could do. We use trigonometry. If you know one side of a triangle and you know two of the angles, you can calculate the entire shape of the triangle. So this is basically surveying, as has been done for thousands of years. The other technique is to use standard candles. If a star is believed to be exactly like another star, but appears fainter, then we say it is farther away, according to what we call the inverse square law for brightness of stars. So the combination of measuring distances and knowing the speed of light enables us to not only measure the size of the universe, but also its age. So the other thing we would like to know is how fast are things moving. Very few things move rapidly enough across the sky that we can recognize the motion. But few things are enough. Now, the other thing that's actually more straightforward to measure is the rate of motion towards us or away from us. So this chart shows the Doppler shift. The Doppler shift has been known since the 19th century, and it was first observed with sound waves. For astronomy, we use spectroscopy. We spread out the light from a distant star with a prism or a grating spectrometer, and when we do this for the sun, we see that there are dark lines across the sky, across the spectrum, which are due to particular atoms and molecules in the atmosphere of the sun. When we do the same thing with distant stars and distant galaxies, we see the same pattern of lines or similar, but the wavelengths are often quite different. And we attribute this to the relative motion of those objects compared to ourselves. So we see the most distant objects in the universe are actually going away from us quite fast. And we measure their velocities by the change of wavelength that we recognize in these spectra. So in 1929, Edwin Hubble made this chart and discovered basically that the universe appears to be expanding. Now, the little dots and circles on this chart represent individual galaxies. He was the first person to be able to measure the distance to other galaxies by studying the standard candles that he saw in them. There are pulsating stars that we recognize as standard candles, and so we can use the relative brightness to estimate distance. And he was also able to measure the speed, from the Doppler shift. So this is the chart that he made, and what we see is that almost all of the galaxies are going away from us very rapidly, at hundreds to thousands of kilometers per second. And if you divide the apparent speed into the distance, you can estimate the time that it has taken to achieve all of these positions. So it appears that all of the distant galaxies are receding from us at a speed proportional to distance. Divide distance by speed and obtain the age of the universe. So in 1929, when he discovered this, It was a very, very important discovery. It was an almost complete surprise for everyone in the entire world, and it was headline news around the world that year. Much better news than the news of the economic collapse that occurred at the same year. So on this next chart, I have illustrated some of the most famous scientists that worked on this subject. In the center, you see Albert Einstein, a very familiar kind of picture. In 1916, he gave us the general theory of relativity, which explains that the effect of gravity is to curve space-time. And so this was a very surprising and puzzling prediction for him, but his calculations were quite quickly verified by measurements. In 1922, the young man Alexander Friedman, that I have shown here on the left side of the picture, was working in Leningrad, and he said, okay, I understand Einstein's equations. I predict that the universe was expanding from an initial condition. And Einstein said that could not possibly be right. In 1927, Georges Lemaitre, who is shown in the center there with Einstein, repeated the calculation, got the same answer, and again Einstein said that could not possibly be correct. So 2 years after that, Edwin Hubble published the chart that I just showed you, and of course Einstein had to apologize for his rude behavior and his failure to understand the nature of the universe. I've shown also some more modern scientists here. George Gamow is shown in the upper right corner. He came from Odessa to the United States, and in 1948 he was working with two young men, Robert Herman and Ralph Alpher, who are shown in the lower left corner. They were calculating the story of the Big Bang, and they actually predicted that the universe should be filled with the heat of the Big Bang radiation. So this is very bright radiation in relative terms, approximately 1 microwatt per square meter, and they predicted it correctly in 1948. It was not possible at that time to measure it because techniques were still very primitive. Now in the lower right corner, I have two very modern scientists, Rashid Sunyaev and Jim Peebles, who have been making calculations for many years, telling us what we should see when we actually go measure the sky. And they have been pioneers in theoretical calculation. So now in my next chart, I want to explain that although everyone pictures the universe expanding from a point, it is not the way that it seems to be to us. What we seem to see is that there is no center of the universe, there is no edge, and all of the astronomers that calculate Hubble's law from observations like these would all believe that they were in the center of the universe. So since they all believe that they are in the center, there cannot be a center. So, so far, we cannot see that there is a center. It's not completely impossible, but no observations have shown any sign of a center or an edge of the universe. So this is a very surprising result from the theoretical calculations, but that also means that it's impossible for us to draw a picture. All I can do is show you a red color to signify that we cannot draw a picture. So we human beings live in 3 dimensions of space and 1 of time, but to be able to look at the universe from outside the universe would require a higher number of dimensions, which we can only imagine and cannot draw. So I'm sorry, we cannot draw you a good picture, and we cannot see the center or the edge if there is one. So here I would like to summarize the history of the early universe. So we imagine that the primordial material, whatever it may have been, may have actually extended infinitely far in every dimension. And there may have been more than the 4 dimensions that we know about. So some small portion of this material did something strange and began to expand. And expanded so fast that even light could not keep up with the expansion. So the small volume that I've just described, 10 centimeters in size, we imagine accelerates very rapidly and becomes the entire expanding universe that we are now able to observe. an extremely implausible story, but nevertheless the one that seems best at the moment. So you could also ask, how did the entire universe fit into that small volume that I've just mentioned? And there are many parts to this. One is that space itself is extremely empty. The stars are very, very far apart from one another. Even atoms are almost completely empty. The atomic nuclei are very tiny compared to the size of a whole atom. And if you could reach inside the atomic nuclei, you can actually tear them apart and find that they are made out of even smaller particles called quarks and gluons. So the calculation says that it's actually not so impossible as you might think for the entire present-day universe to be produced from this very small volume of primordial material. This is the story of what was called inflation and has been known since the middle of the 1980s. So now the next question that you would want to know is, how is it possible that we can exist? Since the universe is expanding, we do not see ourselves expanding. How can we exist? So the short version of the answer is that gravitation, which reaches across the universe, is actually able to stop the expansion for regions of the universe that are slightly more dense than average. So it means that some parts that were initially created in the Big Bang material that are more dense, they will stop expanding, they will turn into galaxies and clusters of galaxies and then stars, and therefore it's possible for the sun to exist and for the earth to exist and for all of the complex life here on earth to exist. It all depends on the fact that gravitation is able to stop the expansion of certain parts of the universe. So here we are. So on this chart I have a short version of the history of the universe. You should see a picture of the Big Bang as measured by the Cosmic Background Explorer and the WMAP Observatory. We imagine that galaxies were formed from small parts that flow together as small streams flow together to form giant rivers. And then in the lower left corner, I have a picture of their nearest galaxy, the nearest large galaxy. It's called the Andromeda Nebula. And you can see that it's very beautiful and has even 2 small satellite galaxies orbiting around it. So I'll skip some of the history of the universe here. I just mention a few major events. When the universe was about 3 minutes old, the atomic nuclei of helium were formed from protons and neutrons. When the universe was about 389,000 years old, the electrons found the atomic nuclei and the gaseous material became transparent instead of being a hot plasma. So when the universe became transparent, then the primordial heat radiation, which could travel only a very short distance before that, afterwards it was able to travel all the way across the universe. So we are now sitting here on Earth, we're able to measure and observe the primordial heat radiation as it was when the universe became transparent 389,000 years old. So after that, then the first stars formed. We've never seen this occur. We calculate there must be something. Then galaxies were formed. And then a great surprise occurs. About 5 billion years ago, the universe began to accelerate again. And so it's going faster and faster every year. A tremendous surprise. So now I'd like to illustrate some of the events that probably happened to the Earth. The Sun and the first solid bodies in the solar system were formed 4.567 billion years ago, only about 1/3 the age of the universe. And so we have this very precisely measured from radioisotopes and the tiny particles that we have retrieved from meteorites. So about 90 million years later, a small planet, probably about the size of Mars, which we have given the name of Theia, it is said to have hit the Earth, and it would have melted everything on the Earth, and materials like carbon and hydrogen would have gone back out into space. The rocky debris was left, and it formed the Earth and the Moon about 90 million years after the formation of the solar system. So then, following that, the Earth began to cool. Then, about several hundred million years later, Jupiter and Saturn are thought to have switched their orbits twice. And so during that period of time, the Earth was bombarded with very many meteorites and comets, and water and carbon probably came to Earth during that period of time. Then at the end of that, life is supposed to have formed. There is fossil evidence that life could have formed as soon as the conditions became suitable here on Earth, that the temperature was low enough and there was enough water for this to occur. Another interesting point is that the early sun was probably much more active and had many, many sunspots on it, and has been getting brighter with time, making the Earth get warmer and warmer. So it's possible even that the Earth was completely frozen solid for some portions of its early life. So as you know, no doubt also, the continents on the Earth have been moving over the course of time. They've been causing tremendous changes of the atmospheric composition. Sometimes it appears that the atmosphere was poisonous, full of carbon dioxide and hydrogen sulfide. At other times, these molecules went back into the rocks through biological and chemical activity of many kinds. So there are these many continents that scientists and geologists have recreated in maps. And very recently, only 100 million years ago, the Atlantic Ocean opened up, separating the Americas from Europe and Asia and Africa. Very recently, the human beings came to live in Africa. It is thought that the origin of the human race is in Africa about 150,000 years ago, very recent, during an ice age where much of the world was dry and much of the world was covered by ice. So I don't have time to tell you all of the stories about this. I would just like, however, to point out that this is also the 400th year of telescopic astronomy. Galileo pointed a small telescope at the sky, and we have been celebrating around the world with the International Year of Astronomy. Now, I have some bad news for the future, and it's possible that all of the carbon dioxide will be used up by biological activity, and it will all become limestone. At that point, the Earth will become very cold because we will be completely we will have no greenhouse gases left. That's a possibility. It may not come to happen. We cannot predict the geological future very well. About 1 billion years into the future, the sun will become so bright then that it will become too hot for us here, regardless of what we may do as living beings. Then in about 5 billion years, the sun will actually swell and become so large that the Earth orbits within the surface of the sun, and at that time, the Earth may be destroyed. At about that same time, the beautiful Andromeda Nebula that I showed you a few minutes ago will collide with the Milky Way, and it will be a spectacular time to be an astronomer, but we will have to move to some other planet. Not that we know how to do that, but some future astronomer on some other planet will have a good time. In about 7.6 billion years, the sun will be extinguished and will become a white dwarf star. Many billions of years after that, we anticipate that the universe will continue to accelerate, the distant galaxies will go away, all the stars will burn out, and it will become dark. But this is only a theoretical prediction, and there are many other possibilities, including the possibility that the acceleration will stop and the galaxies will all fall back together and there will be a cosmic collapse. We don't know, of course. Now, I would like to tell you a little bit of the story of my personal work that led to the Nobel Prize. In 1974, I finished my graduate school at Berkeley, California, after an attempt to measure the cosmic heat radiation from the Big Bang. It was not a successful attempt, but it showed us what we needed to do a better job. And we all knew that a better measurement could be done with a space mission. So in 1976, when I came to Goddard Space Flight Center, we began to design this observatory called the Cosmic Background Explorer. And what you see here in the picture is a sun shield, this yellowish gold-colored cone. Inside the cone are the instruments. There is a collection of instruments. Two of them are inside a helium tank operating at a temperature of 1.5 degrees above absolute zero. And the others are surrounding the tank, and they're just protected from the Earth and the Sun so that they can become cold. So this observatory is still in orbit around the Earth, but it was only used for about 5 years to make the initial observations. So it's called the Cosmic Background Explorer, and one can actually see it in the evening if you know when to look. Now, this is the chart that shows the first scientific result of this mission. What we show here is a prediction of the spectrum of the cosmic microwave heat radiation. The smooth curve is the prediction, and the first measurements that we reported are the little boxes on the curve. You will see that all the little boxes are exactly on the curve, which is exactly what I expected, but it was not a known fact. When we showed this measurement to the Astronomical Society, we received a standing ovation and many minutes of applause. So what it means is that the Big Bang theory is actually as close to proven as possible. There's no real proof of a thing so dramatic as the Big Bang theory, but all of the measurements now agree with it, and this is one of the most important parts of the evidence. So we now really do believe that the universe came from the Big Bang and produced this heat radiation, which is measured here. Now, after many years of effort, we now know that the temperature is exactly 2.725 Kelvin, and that those error bars are very, very, very tiny, only 50 parts per million. So this is the first major result of the observatory. 2 years later, in 1992, we showed this set of charts, and when Stephen Hawking, very famous physicist, saw this chart, he said, "This was the most important scientific discovery of the century, if not of all time." So what we have here is a map of the temperature of this heat radiation from the Big Bang. Each of the ovals there that you see is a map of the entire sky. So the first map, the top one, shows the raw data as they come in. And you see that all we can see is that one side of the sky is a little pink and the other side is a little greenish. And we say, well, that is due to the fact that the Earth is moving relative to the rest of the universe. When we remove that effect mathematically, we see the picture in the middle, and what we now see is a red band across the middle, which is due to the electron population in our own Milky Way galaxy. When we remove that one as well by doing some more mathematics, we see the picture at the bottom, which is a map of the temperature variations across the sky of this primordial heat radiation. And so the differences are very small, approximately 30 micro degrees Kelvin. On the other hand, we believe that these temperature variations are responsible for our own existence. They are produced by dark matter, which is a new discovery from astronomers, and they are responsible for the density variations that enable some regions of the universe to stop expanding and to turn around and become galaxies, stars, and planets. So something like one of these small blobs is responsible for our own existence. Now, we can't see the one that's our own history, but we imagine that ours was like this. So 3 years ago, this month, I received a telephone call from Stockholm saying that we were going to receive the Nobel Prize. And so it's for the discovery of the black body form, and that's the theoretical curve that I showed you with the little boxes on it. And the anisotropy, which is a Greek word, and it means not the same in every direction. So those are the small lumps and bumps that are seen in the colored map. So Then I went to see the King of Sweden, received my diploma, received a nice check, have started a foundation for promotion of science and the arts, mostly for scholarships for young people. So now, however, I would like to say that there are some surprises still open for astronomers. This cartoon says that we frequently obtain a surprise, that the universe is not the way that astronomers have said that it is. And so we'll illustrate one of those surprises here. In 1998 here is a picture from the cover of Science magazine, because it was discovered in that year that the universe is accelerating, going faster and faster each year. And it was discovered especially by these three men in the right-hand picture. They studied distant stars called supernovae, and they found out that the most distant ones they could see were 20% too faint. The result of that is that we believe that the universe has been accelerating in the last 5 billion years, and due to some force which we call dark energy, but in fact we do not know anything about this thing that we call dark energy, and it's not even really a force. So it's pretty clear that this is a potential Nobel Prize-winning discovery. Who knows when we may actually know what this substance, if it is a substance, actually is. But it's one of the most important topics of current investigation in astronomy. So astronomers have a few mysteries open, which we share with physicists. Number one, why is there only ordinary matter, and there is no antimatter anywhere in the universe except very temporary antimatter particles? There are no anti-galaxies that we can tell. The second question is, what is the dark matter? I told you there is dark matter and that it's responsible for the small temperature variations in the microwave radiation. This dark matter is apparently much more abundant than the matter that we're made out of, but it does not produce or interact with light waves, so we cannot see it directly. We do detect that it has gravitational force. So we're very sure that it exists, but no particle of dark matter has ever been seen in a laboratory. What is the dark energy? I just told you that we have dark energy, but we don't know what it is. Now, every student from elementary school to graduate school and on always says, well, are you really sure that Einstein was right about relativity? Are you sure that we can't go faster than the speed of light? And of course, it's still a good question. Astronomers are busy trying to answer the question of how did we arrive here on Earth? How is it possible that the Earth has come to exist? And of course, a more philosophical question is, are we the only human beings in the universe? Are we the only intelligent creatures in the universe? Part of that question is, how is it possible for the Earth to become a place where we can live? And another part is there any other place in the universe that could support life? And of course, another question is, what is going to happen to us in the future? Which leads me to the next project that I'm now working on, called the James Webb Space Telescope. So to explain why we want the James Webb Space Telescope, let me explain about infrared light. Infrared light is like ordinary light that you see with your eyes, but it has a somewhat longer wavelengths. And it comes from somewhat cooler objects. So it's important to us for a number of astronomical reasons. Number one, if we want to look at the most distant universe, the light of the first galaxies that we would like to understand starts out as ultraviolet light, but when it arrives at us, has been redshifted by the expansion of the universe, so it is infrared light. So to learn our history, to look back far in time, we need to use infrared telescopes. The other thing that is important to us is that, as you see here, objects at room temperature, like ourselves, emit infrared radiation, and it's quite different in character from the visible light that we would see. So if we want to study as astronomers what objects are like that are near room temperature, we should study infrared radiation that comes from such objects. So that leads us to the concept for this new telescope. This is called the James Webb Space Telescope, and it is planned as the next great telescope after the Hubble Space Telescope. So it's been in preparations now for 14 years, and it's going to be launched in 2014, according to our plan. This is a very different telescope from any that you have ever seen in outer space or on the ground, because it's made out of segments. It unfolds after it is launched into space, and it's extremely cold. So I'm going to show you how this is done in a moment, but just to tell you who is building it, NASA is the lead organization for this project, and it's being led here from Goddard Space Flight Center, where I'm speaking. We are working this as an international partnership with the European and Canadian space agencies, and we have contracted with Northrop Grumman, which is a large aerospace firm located near Los Angeles Airport, to build the observatory. There are instruments that cover all the infrared wavelengths that we want to study, and they come from Arizona in the United States, from the European Space Agency, and from Canada. So I should also say that this telescope is much larger than any telescope we've ever had in space. The Hubble Space Telescope has a mirror that's 2.4 meters in diameter. The one that we are flying now has a diameter of 6.5 meters, so it's much, much, much larger and will collect much more light from the distant universe. And it's also arranged so it's very cold. I'm going to show you the orbit that we put it in, but what you see in the picture here is a large, what you see here is blue. It's actually a giant umbrella. It is made of 5 layers of plastic, and the plastic layers protect the telescope from the heat of the sun and the earth. So the telescope will be capable of achieving a very low temperature of approximately 40 degrees Kelvin, so that it does not emit infrared light itself. So here is the orbit that we will use for the telescope. It orbits around this place called the Sun-Earth Lagrange point, L2. L2 is about 1 million miles, 1.5 million kilometers away from Earth. And we put the telescope out there so that the umbrella or sun shield can protect the telescope from the heat of the sun and the Earth at the same time. So these points have been known since the 18th century, discovered by mathematicians. Now, this illustrates a couple of places where the model of the telescope has been. We had the model built to sort of show the world how big is the telescope and how powerful it may be. So it's been traveling around the world. It's been to many cities. Here it's shown as it was in Munich, Germany, a year ago, and as it was in Washington the year before that. So you see that it's very large. Now here I hope that you will be able to see the movie showing how the telescope unfolds after it is launched. This telescope is much larger than the rocket, and so it has to be unfolded after it is launched. And at first the telescope solar power cells come out, and then the telemetry antenna for the radio waves, and then the plastic shield comes out. This is all done by remote control. Motors and actuators cause this to happen while we sit here on Earth, making sure that it's all working correctly. So the last thing for it to happen, for it to do, is for it to adjust the telescope to the right shape. You will see in a moment that the mirrors come to form the giant hexagon that is the primary mirror. So there is the telescope as it will be used in flight. Truly a tremendous challenge for engineering, but obviously one that we must solve to make this observatory work in space. So we had many inventions to make to show that this observatory would work. Probably the most important one for us was the what we call mirror phasing algorithms. When the Hubble Space Telescope was launched, it did not work correctly. There was an error in the mirror. So it was necessary to learn how to measure the error of the mirror and to calculate how to make a repair. So the mathematics was developed for the Hubble Space Telescope repair, and now because we know how to do that, we can use the same mathematics to adjust all 18 pieces of the mirror to the correct shape and position so that they function as a single giant reflecting mirror. So now I just wanted to illustrate that we have to practice this adjustment with a small telescope. This is a model that can be adjusted in exactly the same way as the telescope in space. So we've learned how to do this and demonstrated that it does work. I would like to show you just for a moment the engineering drawings of the instrument packages. I can't really explain these to you. I just wanted to say that they're coming along very well. And Europe is contributing the near-infrared spectrograph in the upper right side there, and the mid-infrared instrument on the lower right picture. So all of these are coming along beautifully, and they will begin to arrive at Goddard Space Flight Center next year. One thing I wanted to show also was that we will test the telescope. This is the giant test chamber which the astronauts used when they were getting ready to make their trip to the moon. They rehearsed their operations inside this test chamber. We are now preparing this test chamber to cool down to the very low temperature that's necessary so we can test our telescope inside as well. Now I'd like to talk a little bit about the astronomy that people hope to do with this observatory. This picture was taken quite recently with the Hubble Space Telescope, and the startling thing that I want to point out to you is there's a curved image in the upper right corner, which turns out to be caused by the gravitational force of the galaxies that you see in this picture. The curved pink curve there is actually the image of a much more distant galaxy that has been distorted by the gravitational field of these galaxies that you do see. So nature has provided us an additional lens out there in space to bend and concentrate the light of even more distant galaxies. And if we can find these places, we can see much, much farther than we ever could see without knowing about them. So we anticipate that the James Webb telescope will do the same, but even better. So the next picture here shows that we have found a number of galaxies that appear to be held together by dark matter. These are galaxies photographed by the Hubble Space Telescope. They're all very nearby, and they're very small. But we calculate how massive they must be, and we calculate that mass could only exist in the form of dark matter that's necessary to hold these small galaxies together. So it's clearly one of the great intellectual challenges of our age to find out what is the dark matter and the dark energy that fill our universe and cannot be seen in our laboratories. Now the Hubble telescope has given us these beautiful pictures of galaxies interacting with each other. These galaxies are, as they are relatively close to us in relatively recent times, we think that our own Milky Way galaxy may have done this as well, and may have collided with other neighboring galaxies in its history. And of course, I told you we think that it will happen to us in about 5 billion years when the Andromeda Nebula comes towards us and collides with us. So it will be a spectacular event. Now, I think you may even be able to see a computer-generated movie of a collision of two galaxies. I hope this is working for you. For just a moment, the computer-generated movie looks like the picture in the upper center of the chart here. and then you see what will happen to the galaxies as they have complete their collision. So this is a possibility for our own galaxy as it collides with the Milky Way. We would love to know how stars and planets form. Astronomers have been drawing pictures like this one for many, many years, but it's still pretty much a theoretical prediction. It's very hard to observe this process forming because stars happen to form inside dusty regions of the sky where we cannot see them. Here is one of the most famous pictures taken with the Hubble Space Telescope. It's called the Eagle Nebula, and it's a place where stars have just formed. Very recently formed stars are here, and you can see that they're burning very brightly and making the dust clouds begin to evaporate. But we think that the stars that we now see were formed inside the dust clouds many hundreds of thousands, many millions of years ago, and that we would definitely like to see inside the dust cloud to see how this process works. So with infrared light, we can actually see the same region, and it looks very different. So infrared light will go through the dust clouds and enable us to see stars as they were being formed, and help us understand the process. Ideally, over the course of time, we would learn how the Earth could be formed around a sun that would be formed inside one of these dust clouds. Now, very recently, it's been recognized that we can even detect planets around other stars. When I was a young person, it was known that was never going to happen. It was completely impossible to imagine how this could be done. But it has been done. This is a drawing based on a picture that was made with the Hubble Space Telescope, and it shows that there is a ring of dust orbiting around a star called Fomalhaut in the southern sky, and it was predicted that there would be a planet inside this dust cloud. And just last year, it was actually measured. The picture in the lower right-hand corner here shows you the star Fomalhaut as it was observed more than once, and you see two little, in the inset picture you see two images of the planet as it moves around inside the dust cloud in the year 2004 and 2006. It's even now possible to see these pictures in the other parts of this photograph that are made with telescopes on the ground. So when the planets are very bright, and when we use very advanced optics in the telescopes on the ground, it's possible to see these little planets, or I should say these large planets, orbiting around other stars. So what's especially exciting very recently is shown in this movie. Once in a while, a planet passes between us and the star that it's orbiting around. So this is showing what's been seen many times already, a planet blocking some of the light of its star. And half an orbit later, of course, the planet will go behind the star, and the star will block the light of the planet. So you see the total amount of light is diminishing while the star blocks the light of the planet. So if we can take the difference between the brightness that we see when they are not aligned, and then the cases where they are aligned and one is blocking the light of the other, then we can determine how much light came from the planet. We can determine some properties of the planet, even some of the light from the planet, even some of the starlight will pass through the atmosphere of the planet, and we'll be able to learn about the atmospheric composition of the planets as it goes in front of its star. So this has already been done with telescopes in space. The Hubble Space Telescope has done this. The Spitzer Space Telescope has done this, and then very recently the European telescope called CORO has done it. So we are building up a large catalog of stars with planets that can be seen in this way. So over the course of time, we have hope eventually to look for stars that have planets like Earth. There's a mission called the Kepler project just launched this year, which in the next few years should discover planets like Earth orbiting stars like the Sun. So it's quite possible that in the next few years you will hear an announcement that another Earth has been found. And it'll take us a little while to determine whether such another Earth could could support life. But anyway, it's coming. I would like to close by saying there are a few other places that one can also look for life in the solar system. I think everyone has heard that Mars could have been alive and has been wet, has water just under the surface in frozen form, and is ice now. There are other places as well to look. Europa is shown in this picture. Europa is a satellite of Jupiter. It has an ocean that is covered with ice, and you can see these brown streaks on the picture are where material has come up from below in the spaces between the ice. So this looks like the Arctic Ocean with ice sheets on it, and so certainly this is a very interesting place to go hunting for life in the solar system. We know that it cannot exist on the surface, but it could possibly exist in the ocean under the ice. In the very long term, many decades in the future, we hope to build an observatory like this that would study the light from planets around other stars. Whether or not this is the exact observatory that would be built, we don't know. But the little picture in the lower right illustrates that there are certain chemicals that you would look for in the atmosphere of another planet to see if it is alive. If you could find this combination of water vapor, carbon dioxide, and oxygen or ozone, you would say this planet is very much like Earth. Particularly since the oxygen on the Earth comes from life, from plants and algae. We would know that if we see another planet that has oxygen in its atmosphere, that it probably is alive just like the Earth. We would not know if it's got intelligent life, but we would know that it has life. So I will conclude by saying there are many places to learn more about this project. The James Webb Telescope has its own web page. Cosmology has its own web page, the Lambda website. The NobelPrize.org website has many lectures, and you can read them there. And I even have a small book, a paperback book, unfortunately still only in English, I think, called The Very First Light, that tells the story of the Cosmic Background Explorer satellite and what it felt like to go to receive a Nobel Prize from the King of Sweden. So I would like to conclude, and I will be very happy to have questions from you. Thank you very much for your attention, and thank you for the questions.
Спасибо, Джон, за прекрасную лекцию. Я потрясена, как можно было в 1 час упихнуть такой гигантский объем информации, потому что тема необъятная. А вообще этот телескоп такой смешной, честно говоря, на телескоп совсем не похож. Но я думаю, давайте мы поблагодарим Джона Мазера, поаплодируем. Джон, я боюсь, что времени на передышку у вас практически нет. Но буквально 1 минута, пока я подойду к столу, где у меня компьютер с вопросами, которые поступают к вам по интернету. И сейчас мы начнем отвечать на вопросы. Дорогие друзья, давайте мы будем чередовать вопросы, поступившие по электронной почте, и вопросы, которые есть у вас в зале. И, наверное, мне должен будет кто-то помогать. Хотя, впрочем, я могу побегать. Мне будет помогать Михаил. Замечательно. Итак, если я сажусь за стол, то в какой микрофон мне говорить? Который на столе. Все работают. Прекрасно. Итак, как меня учили, нажимаем кнопочку «Обновить». Уже вопросов много. Смотрим, что тут. О, Господи. Так, ну что ж, давайте начнем с такого хорошего вопроса, на мой взгляд, любопытного. Вопрос задает Владимир, непонятно из какого города. И звучит он так. По самым последним данным, Большой взрыв произошел 13,7 миллиардов лет назад. Значит ли это, что радиус Вселенной равен 13,7 миллиардам световых лет?
Yes, that's the observed size of the universe. On the other hand, we imagine that there is much more universe beyond what we can see. So the universe could actually have infinite size, but we would not know.
А этот размер меняется?
Does this distance change?
Yes, as the universe gets older, the amount of time that we can see gets larger, and so, yes, astronomers living another billion years in the future will say that the universe is 14.7 thousand million years old.
Хорошо. Тогда у меня вопрос глубоко личный, он меня страшно беспокоит.
Now I have a
Мы с
personal
вами, Джон,
question for
начинали
you.
этот разговор 2 года
We
назад,
started
помните, на День Благодарения.
This
Но вот ответ я
2
хочу
years
все-таки
ago, but I would
получить.
like to
Если
get
мы
my answer.
принимаем
If we
теорию Большого взрыва как теорию,
agree
похожую на
with
правду,
the theory of the Big
то мы
Bang,
должны согласиться, что в
then
момент
we
Большого
must
взрыва
agree
образовались материя,
at the
пространство
moment of
и
the Big
время.
Bang,
Правильно?
the matter and time were created.
Что-то мне...
Is it so?
Что он отвечает? Правильно?
In physics, we're actually not able to describe the creation of space and time. We only describe the process of change.
Нет.
So
Джон,
we are
вопрос.
unable to answer that question.
Да, понятно. Но мы сейчас говорим о гипотезе, что мы полагаем, что было так. Но Вселенная расширяется с ускорением. Значит ли это, что ускоряется и время, родившееся вместе со Вселенной? Джон, успокойте. Какой канал? Нулевой или первый?
No, what we see is only that the distance is accelerating. So we measure time with the same kinds of clocks that we always use.
То есть время не ускоряется. Но мы-то чувствуем обратное. Джон, вы чувствуете, что время ускоряется? Нет?
Well, yes, time seems to go quicker and quicker every day, but the clock says no.
Хорошо. Вот еще один вопрос, который поступил к нам в интернете. Задает его Александра, журналистка. Верно ли, что согласно данным спутника Коуп, Вселенная выглядит совершенным овалом? Но почему овал, а не сфера? Ведь при взрыве материи продукты взрыва равномерно разлетаются в разные стороны, занимая сферическое пространство. Почему наша Вселенная овал, а не сфера, если это так?
Yes, the oval that I showed is just a map. Just as we show the surface of the Earth as an oval, those ovals are also just a representation of the entire sphere. So I don't have a spherical movie screen for you.
Значит, Вселенная овал. Сфера. Все прослушал, прошу прощения. Хорошо. Еще вопрос о вселенных. Кстати, вот вопрос поступил к вам от уважаемого и горячо любимого нами астронома, астрофизика Владимир, который звучит так. Сколько стоит аппарат Коуп? КОБ. Ну, КОБ, да? Сколько стоит в валюте, пожалуйста, в конкретной? Джон, сколько денег на него потратили?
Okay, that's an interesting question. I think at the time that it was built, it cost about $300 million US. In modern money, that would be more money because of inflation of currency. But another way of saying it is it took about 1,500 people operating for several years to do it. So it's much smaller than the James Webb Space Telescope, which has much more budget and takes much longer. and is much more powerful.
В общем, золотой телескоп, и тот, и другой. Гигантские деньги. Так, еще вопросы смотрим.
Okay, other question.
Much more expensive than gold.
Дороже, чем мы можем представить. Вот вопрос от Дмитрия, медицинского работника из Москвы. Верите ли вы в то, что вселенных много, и большие взрывы происходили неоднократно? Или время и пространство начинаются только от одного, нашего Большого взрыва?
I think it's quite possible that there are other universes, but that we will never be able to prove it. Only mathematicians can speculate about this for us.
Как жалко-то, как скучно, не можем доказать. А я бы так не отказывалась бы. Так, дорогие друзья в зале, есть ли вопросы? Есть ли вопросы? Так, я прошу...
Мой вопрос, меня зовут Ольга Колесниченко. Мой вопрос про другие физики, если так можно выразиться. Вот некоторые ученые говорят, что Вселенная полна загадок, и можно найти другие законы физики. Вот вы в это верите, и можно ли это доказать вот такими космическими исследованиями? Спасибо.
Well, it certainly is true that we do not know all of the laws of science or of physics. So far, what seems to be true is that each new discovery is a small or modification of the old ones. But I already told you some great mysteries that we have. We do not know what is dark matter. We do not know what is dark energy. We do not know what is the nature of quantum gravity. We do not know whether string theory is correct theory. So there are huge mysteries still open in the physical sciences, and of course biological sciences are making discoveries at an immense pace these days. So we do not know what we will be discovering, but I think it will be fascinating, and we have many centuries of scientific discovery in front of us, maybe millions of years.
Спасибо. Джон, я поздравляю вас. К вам огромный интерес проявляют российские женщины. Я попытаюсь обобщить эти поступающие вопросы, но в целом они сводятся к одной группе. Джон, женат ли вы? Кто ваша жена? Астрофизик? Или она занимается, работает в другой области науки? Ну и вообще.
Okay, well, I'm happy to say that I am married, and my wife is a ballet instructor. She teaches classical ballet to adults and has been doing that most of her life. And so she is beautiful and talented herself, and she is not a scientist. But it's a good partnership.
Да, теперь мне понятно, откуда у вас такая прекрасная форма. Это за вами Джейн следит, все понятно. Вот здесь еще в интернете есть огромная группа вопросов, которые можно объединить и сформировать, наверное, под одним. Вот я сейчас пытаюсь его сформулировать, который звучит условно так. Верят ли астрономы в Бога? Вот такой короткий и простой вопрос. Верят ли астрономы в Бога?
I think the short answer is yes, some do and some do not. But of course, the astronomers that believe in God will probably believe in a different form of God from the ones that have been described for many thousands of years in our traditions. So we picture a God as a being floating in a cloud in the sky, and so I don't think astronomers will see that kind of God. We will have a different kind of God.
Спасибо. Вот еще есть группа вопросов, которые тоже, наверное, имеет смысл объединить. Это такой вопрос, состоящий из трех в логической последовательности. Артем спрашивает, что было до Большого взрыва? Ольга из Новосибирска интересуется, почему произошел Большой взрыв. И, наконец, Алексей Александров спрашивает, когда будет новый Большой взрыв? Вот что, что вы нам на это ответите?
I think the fair answer is we do not know. The next Big Bang may be happening right now somewhere in some other universe that we cannot see. But our own universe, we think, will continue to expand for many billions of years before it might possibly turn around and collapse. So it's not soon for us. But because we cannot see if there are other universes, we cannot tell about whether they are also expanding. So I'm sorry I can't answer that question.
Ну что, вот тут поступило для вас, Джон, приятное такое приглашение съездить на Урал. Вас хотят накормить уральскими пельменями. Вот интересуется Виктория из Екатеринбурга. Бывали ли вы у нас в России когда-нибудь?
Yes, the answer is yes. I have visited Russia with my wife as a tourist many years ago. I think it was around 1986 or 7. I don't remember the exact year, but it was the year that Ronald Reagan visited Moscow. So we saw many beautiful things in Russia then. All the way from Sochi to Leningrad.
Ой, вот тут уже поступают не только вопросы, но и слова благодарности. И, конечно же, я с удовольствием их переадресую вам. Спасибо вам огромное за лекцию. Очень признательно, очень интересно, замечательно. Тем не менее, есть вопросы, которые лежат за плоскостью, скажем так, науки. Вот, например, вопрос Станислава, преподавателя информационных технологий из Улан-Удэ. Он спрашивает, что представляет собой темная энергия Вселенной? Уж не пристанище ли это душ умерших? Ну, извините, какой вопрос?
Oh, goodness. We astronomers cannot possibly answer that question. I think we need to consult our religious leaders. But I think they will not know either.
Да, спасибо. Вот Сергей спрашивает вас, как далеко видят современные телескопы? И на какое расстояние нам откроется космическое пространство после ввода нового суперорбитального телескопа?
Well, right now, the farthest that we can see is approximately 10 or 11 billion light years, which gets us within a very short time from the beginning. We can see with those telescopes within about 800 million years after the explosion, after the Great Big Bang. The new telescope we hope to be able to see within 200 million years of the Great Explosion, so much closer. In terms of physical distance, we do not see very much farther, but we see much closer to the Big Bang itself.
Спасибо. Еще вопрос, Александра.
Another question, Alexandra.
Спасибо вам огромное за лекцию. Вы говорили, что многие экспериментальные данные подтверждают теорию Большого взрыва. И все же, насколько возможно, что эта теория неверна? Ведь в истории науки уже не раз были случаи, когда опровергали, казалось бы, совершенно верные теории. Какова вероятность того, на ваш взгляд, что теория Большого взрыва неверна?
So could it be there was no Big Bang? Yes, there are many things that might have been a little different and surprising. The idea of the Big Bang is hard to escape. Since Edwin Hubble showed us his picture in 1929, it's been clear that something very exotic and strange occurred to make the galaxies appear to fly apart. But the details of what that event was are still open to discussion. It has to be a lot like the Big Bang, but it doesn't have to be exactly the same. So, for instance, when we finally discover a better story about quantum gravity or string theory, maybe we will discover that Einstein's theory of relativity is not quite correct. Then we'll have a new story for you. I think it will resemble the Big Bang, but it might be different in some details. That's my guess. But as you know, we do not actually observe the Big Bang directly. We have many observations that we must interpret. So it's always possible that we will be surprised.
Дорогие друзья в зале, есть ли вопросы? Или я продолжаю? Да.
Прошу прощения, может быть, задам несколько частный вопрос, но, на мой взгляд, он очень интересный. Недавно на сайте Архив.орг была опубликована работа, авторы которой доказывают, что темное, холодное, так скажем, пятно в микроволновом фоне, которое, насколько я понимаю, как раз связано с темой вашей Нобелевской работы, было всего-навсего ошибкой вычислений, что на самом деле его нет, и мы имеем дело с абсолютно изотропным фоном. Спасибо.
Ой, не по-доброму.
Well, I haven't seen the material that you're describing, but of course many astronomers worked with us to try to make sure that there were no mistakes. So of course we don't think there was a mistake, but one could never be completely sure. But our observations have been confirmed by other astronomers. New telescopes have been flown. The microwave spots that we saw have been observed again by many astronomers with equipment on the ground and in space. So we're pretty sure that that's a correct measurement. Similarly, the spectrum that I showed was also observed by another experiment. So although mistakes are possible, we don't think they were very large. So I think the basic answer is still correct.
Спасибо. Да, вопрос, пожалуйста. Наверное, имеет смысл представляться, друзья.
Здравствуйте, Джон. Меня зовут Алла. Меня интересует такой вопрос. Я знаю, что Луна отдаляется от Земли, если я не ошибаюсь, на 3 сантиметра в год. Вот мне интересна гипотетическая ситуация, когда Луна потеряет связь с Землей. Что будет с Луной и что будет с Землей?
Катастрофа будет. Мы не можем без Луны.
Okay, so when the moon loses connection with the Earth, well, it will be very far in the future. I don't know whether the calculation says that it will stay with us for a long time. If you multiply 3 centimeters per year by, say, 5 billion years, that's a lot of meters, so it'll get farther away. Eventually, the moon could escape. Now, I don't know whether it will happen before the sun expands and swallows up the Earth. But if the moon escapes before the sun swallows us up, then we would, of course, lose the tides that the moon produces. So the ocean would stop going up and down as it does, nearly as much. We still have tides from the sun. And the other major effect that the moon has on the Earth is to make the spin axis of the Earth change with time. So because of that, that would also change. So I'm not sure. I don't really know. That's a good question. We should find out.
Ну вот пусть НАСА займется и разберется с Луной. Я вот в продолжении этого вопроса, Алла, вашего, пока еще Луну мы не потеряли, вот есть такой вопрос. От Евгения Сидорова из Риги, Латвия. Мы располагаем потрясающими снимками, полученными с помощью орбитального телескопа Хаббл о глубоком космосе. И мы эти снимки, кстати, видели на экране. Но почему нет фотографий с высоким разрешением поверхности Луны и других планет нашей Солнечной системы? Откуда такая выборочность? Задает вопрос Евгений Сидоров.
Well, actually, Evgenia, we do take pictures of the objects that are close by and interesting, but it's easiest and best to actually send a space mission to there to get the pictures. So we have sent already space missions to Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, as well as to some asteroids and comets. So it's much better to get a picture close up than it is to take a picture from far away with a big telescope. So the pictures are available, and you can find them quite easily on the internet.
Хорошо, есть вопросы? Да, пожалуйста.
Джон, здравствуйте. Я учитель физики Калякина Светлана. В России школьный курс астрономии исключен из преподавания в средней школе. Как обстоит дело в Америке с преподаванием астрономии? И каков ваш взгляд личный на то, нужен ли предмет астрономия в школьном курсе, или он должен быть интегрирован с физикой? Спасибо.
At least where we are, astronomy is one of the most popular science courses. It's attractive for students. It talks about our own history, and students can see the subject with their own eyes at night. So I think astronomy is one of the most interesting subjects for students, and I hope that we can continue to teach it everywhere. And so it's one of the things that helps students get interested in science to begin with, and from there go on into the more difficult areas of other kinds of physics and chemistry and biology. So I think it's very important for us to continue to offer it to the schools.
Спасибо. Готовьте вопросы. Вот есть, опять перейдем к личному. Сергей Чернов из Курска спрашивает. Здравствуйте, мистер Мазер. Смотрите ли вы сериал на NBC The Big Bang Theory? И видели ли хоть одну серию? А у нас его показывают, нет?
I have not seen the series, but it is said that it is very funny, and I have heard that the scientific discussions are correct. So I don't know. I haven't seen it personally, but it's supposed to be a lot of fun.
Я, честно говоря, думала грешным делом, что вы эксперт в этом сериале, Джон. Вот есть огромная, гигантская группа вопросов катастрофического характера. Всех интересует конец света в 2012 году. Что планета Нибиру окажется в опасной близости от Земли, все это столкнется и, в общем, конец. Евгений из Ярославля, Илья из Петербурга. Ну, в общем, здесь очень много вопросов. Всех интересует конец света. Вот Слава Махоткин, монтажник. Что вы думаете по этому поводу, Джон? Будет у нас конец света? Столкнемся мы с этой Нибиру? Или как это все будет? Что говорят астрономы?
I think astronomers do not believe any of those stories. I believe there's some story that the ancient calendar from the Mayan inhabitants of Central America will not have enough digits to represent the next year in 2012. But I think that if they were alive today, they would just add another digit. So I don't think there's a problem with the calendar. I'm not buying any insurance about that.
Хорошо, спасибо, успокоили. Вопрос от Мурата Мусаева, финансиста из Баку. Как вы думаете, это продолжение, наверное, к предыдущему вопросу, как вы думаете, как долго может существовать наша цивилизация и через сколько веков человечество будет иметь возможность путешествовать в другие галактики?
How long will our civilization last? Well, I do not know, but we certainly can see that everything changes very quickly these days, that much more quickly than any time in history. So I can't really predict when we can go to another galaxy. Right now, there's no scientific knowledge that tells us how to go to another galaxy. At the moment, it is even too difficult to go to the nearest star, which is much closer. Even just to get to Mars, which is very close, is too difficult for us today. So we do not know how, and we may never be able to do it. So I'm sorry, it's too difficult, I think.
Хорошо, тогда вам вопрос попроще, совсем простой, от Татьяны, астронома из Иркутска. Сотрудничаете ли вы с российскими астрономами и астрофизиками? И вообще, делаете вы различия между астрономами и астрофизиками? Ну, у нас назовешь астронома астрофизиком, обидится, или наоборот назовешь, тоже обидится. То есть у нас есть какое-то различие. Вот чувствуете ли вы это различие? И кем вы себя считаете, астрономом или астрофизиком?
Okay. Yes, I have occasional contacts with my Russian colleagues. Rashid Sunyaev is the one that I see most often because he travels occasionally here. The difference between astronomers and astrophysicists is not very large. The astrophysicist attempts to understand the details of the physics behind the observations. The astronomer takes the observations and interprets them as well. So I don't think there's much difference. And I think of myself as an astrophysicist because my original degree is in physics, but there's not a very large difference.
Спасибо. Есть вопросы в зале?
Здравствуйте, меня зовут Анна. У меня вопрос относительно темной материи. Вы сказали, что новый телескоп, возможно, даст какие-то данные по поводу темной материи. А все-таки и что сейчас очень мало что известно. Все-таки что-то известно или вообще ничего? И если что-то известно, вы могли бы уточнить, что конкретно понятно про это?
Okay, well, the dark matter is recognized by its gravitational force. So the way that we study it is to find galaxies and clusters of galaxies where there's enough dark matter to bend light or to affect the orbits of the stars. So it's been known for many, many years that the galaxies do not spin the way that they should spin if the only matter there is made of stars and gaseous material. So for maybe 50 years we have known there's a problem with dark matter, but we did not know what it is. And so astronomers can tell you much more about where the dark matter is and maybe eventually how it got that way. To really learn about the dark matter, we need to have a particle made in the laboratory, say at the Large Hadron Collider in Europe, or maybe even in a laboratory where a natural dark matter particle might collide with our detector. And then we could learn a lot more about dark matter. Right now it's a very large mystery, and I don't think it's going to be an easy problem.
Вопрос?
Здравствуйте еще раз, Джон. Снова Алла. Меня интересует вопрос из разряда парадоксов. Вот скажите, каким образом в стране, которая достаточно долгое время занимает лидирующие позиции по космологическим инновациям и по изучению космоса, и в которой астрономия является таким популярным предметом, так много людей верят в астрологию и в прогнозы, в гороскопы, я имею в виду, астрологические. То есть каким образом это живет и существует вместе в одной голове? Меня интересует такой вопрос.
Well, I think your question is a question for people in a different area of science, psychology and sociology, but it's a puzzle to me as well. I'm surprised. I thought personally, after many centuries of educational progress, that more people would understand astronomy, but they don't.
Ну вы сами-то гороскопчики посматриваете, нет, Джон? Про себя-то нет?
Well, I don't use them, but my wife finds them every day for me and tells me, and we always laugh about them.
Вот, Джон, начните с себя и с тех, кто рядом. Джон, вот вопрос еще поступивший. Вот вопрос еще поступивший к вам. Какой, на ваш взгляд, на какой самый важный вопрос о нашей Вселенной вы надеетесь получить ответ с помощью нового Джеймса Вебба Space Telescope? Вот можете выделить самый-самый важный вопрос о Вселенной?
Well, I think that for me, one of the most important questions is the formation of the first stars and galaxies. It could possibly produce a great surprise for us. It is suggested, for instance, that perhaps the first stars were not made out of the ordinary matter that we see today, but were actually formed by dark matter, and that they may have burned dark matter in their centers. So this is one of the more surprising possibilities, and I think it would be very exciting if we could learn whether this is true or not. The other thing that I think could be wonderfully surprising would be to detect evidence of life on another planet. And so I don't know whether the James Webb Telescope can do that. Probably not, but some future telescope not too far in the future possibly will tell us about planets that are alive elsewhere in the universe. I think that would be a very important thing for science and for culture.
Хорошо, а вот студенты из Санкт-Петербурга интересуются, а чем вы займетесь после того, как телескоп будет запущен? Какая ваша следующая цель? Может быть, они сами ищут цель и хотят, чтобы вы им подсказали?
Well, for me, the next challenge will be to use the telescope to decide what I think is the most important scientific project and to try to obtain the observations that would help make an advance in that area. But also, maybe I will start work on the next telescope that follows this one. I do not know what will happen in 5 years.
И все-таки, Джон, вы знаете, ваш этот телескоп новый, совсем не похож на телескоп. Какая-то досочка с парусом. Вот у вас есть дизайнер проекта, дизайнер телескопа? Такой дурацкий вопрос. Кто вот эту конструкцию вот так вот придумал? Какой-то вот такой он, особенный. Я не права разве? Какой-то он не телескопный. Нет? Не похож.
Yes, we understand. It was, of course, partly my idea and partly the idea of many other people. But it is required to do two things. One is to make the telescope cold so that it is protected from the sun and the earth. Now, the Hubble Space Telescope looks more like a telescope. It's a tube and it's orbiting around the earth, but it is kept warm by the heat of the earth and the heat of the sun. For us to make a telescope that is cold, it must have a special shade that protects it from the sun. And the other side must be open to outer space so the heat can escape. So that's why the telescope looks as strange as it does. The other part of it is that because the telescope must be larger than the rocket that carries it into space, it must be folded up. And so that makes it look even more strange. It's because of the special requirements that we have.
Ну да, картинка красивая, когда он так вот там разворачивается. Все, да, замечательно. В общем, дизайнера у вас нет, я поняла. Переходим к личному вопросу. Вопрос непонятно от кого. Помимо текущих проектов, которыми вы занимаетесь в НАСА, что в астрофизике интересует вас лично?
My personal interests in astrophysics, I think, are very closely connected with my work for NASA. I think I described already that I'm interested in the first stars that formed after the Big Bang and in the process for formation of planets and possibilities for life. But currently, most of my work is connected with engineering to make sure that this wonderful new telescope will function correctly when it is launched. So I work with scientists and engineers to make that true.
Понятно. Давайте, Джон, поговорим о чувствах, наконец. Вот Павел Сорокин спрашивает. Уважаемый профессор Мазер, что вы чувствовали, когда вам вручали Нобелевскую премию?
Well, I had many feelings, of course, when I received the prize. One feeling is that I'm amazed myself to be on the same list of people as Albert Einstein and the great scientists of the past. So another part is that I know that the work that I did was part of a very large team, and so I always wanted to make sure that people could see that it was a team project in modern times that is required to do one of these new discoveries. Not all of science is done in large teams, but at least in astronomy, it takes a very large team to build a new telescope or to build a new observatory of some sort. On the other hand, you see in biology and sometimes in astronomy that a very small team of people still can make a great discovery. Also, it was wonderful just to be celebrating, to meet famous people besides myself, and to get acquainted, to meet the King of Sweden, to meet the Prime Minister, and to have a banquet in the Great Hall with 1,000 people is a totally overwhelming event.
Ну, мы вас поздравляем еще раз. Уже известно, в какой за 3 года последних. Но, Джон, вот скажите, вы же согласны, что среди лауреатов Нобелевской премии очень много американских ученых? Как вы считаете, это нормально или это странная ситуация, нет? Такой искренний ответ я жду. Не политкорректно.
Well, yes. I'm certainly pleased for my country that many Americans have won the prize, but I think it's somewhat of an accident of history that there was a period of time when the United States had very generous support for science and many other countries could not do that. Now I think the world is changing rapidly. Other countries are becoming much more prosperous and producing very many brilliant scientists and engineers. And America now worries that it will no longer be the leader that it has been for so long. So we have reports for our Congress very frequently complaining that we do not educate our students well. So I think you may see in the future that many more prizes are going to other countries.
Джон, я просто вам настоятельно рекомендую. Вы же, как Нобелевский лауреат, имеете право выдвигать на Нобелевские премии. Давайте начинайте уже выдвигать российских ученых. Ну что ж такое-то? Это будет как-то логично и справедливо. Вопросы в зале есть? Вот сзади вас вопрос.
Здравствуйте, Джон. Меня зовут Валентина. Скажите, вы верите в Нострадамуса? Спасибо.
Do I believe in Nostradamus predictions? Well, I don't actually know what they are, so I don't know. But probably not.
Не знаком? Отлично. Не знаком. Мы тоже не знакомы. Вот вопрос еще, пожалуйста, в зале. Мариночка, вон там, в конце. Молодой человек.
Здравствуйте, меня зовут Алексей. Я снова хотел бы задать космический вопрос. В чем отличие между темной материей и темной энергией? Спасибо.
По существу вопрос-то.
Okay, dark energy is the name that we give to the force that we imagine causes the universe to accelerate, to expand more rapidly every year. The dark matter is the name we give to what we think are small particles that are like ordinary matter particles but do not interact with light waves. So they have gravity but not, they don't cause the universe to accelerate. Now, are these really true things? Since we cannot make any of them in the laboratory, it's very hard to know for sure. So in the future, it may become that we believe that dark energy is actually just a different way of gravity, that maybe Einstein's theory of gravity is incomplete, or that quantum gravity has a new prediction for us. Similarly, dark matter may come as a result of some experiments in the laboratory, and maybe we will now understand them in the next 10 or 20 years. But I do not know. I'm sorry, we can't really be sure.
А вот вы уверены в Большом адронном коллайдере, Джон? Вот вопрос тут вас задает Алексей Александров. Боитесь ли вы Большого адронного коллайдера? Не с ним ли будет связан будущий новый Большой взрыв? Большой адронный, какая аббревиатура там английская? Large, адрон, адроник, LHC. LHC. Хат.
I guess people have worried that when we turn on the new Hadron Collider, that a new Big Bang could occur. But we think it's very unlikely because nature already produces very high energy particles in space. You know, cosmic rays come to us with much energies that are much higher than any that are produced in the Hadron Collider. So nature has already done the experiment. And if there were going to be a new Big Bang produced by those kinds of interactions, it would have already occurred. So we don't think it's very dangerous.
Джон, понимаете, в чем проблема? Проблема в том, что обществу нужны определенные ответы. Вот когда в научном сообществе есть какое-то количество физиков, которые говорят, что есть вероятность отличная от нуля, что большой адронный коллайдер взорвется, вот этого достаточно, чтобы люди были напуганы насмерть. Вот можете сказать, положить, но почему физики не говорят определенно? Никакой угрозы большой адронный коллайдер не несет. Почему нельзя сказать так точно и определенно? Почему даже физики начинают размышлять и опасаться и осторожничать? Я его спрашиваю.
Yeah, in my opinion, there is no danger in the collider work. If there were danger, the universe would already be over, because nature already produces these kinds of collisions by natural processes, and nothing bad has happened.
Ну хорошо, нет опасности, уже стало легче дышать. Так, дорогие друзья, вопросы? Да.
Владимир Сурдин, Московский университет. Видите ли вы возможность, техническую возможность, заглянуть в прошлое Вселенной глубже, чем та граница, с которой к нам приходит фоновое космическое излучение?
Что мы там увидим?
Реликтовое излучение.
Yes, there is a possibility. You know that the microwave heat radiation from the Big Bang has many properties. One of them is polarization. You know, if you wear polarized sunglasses and you turn your head, the sky can be brighter or darker. And so we can measure the polarization properties of the cosmic microwave radiation from the Big Bang. And it is predicted that those polarization properties may arise from gravitational waves in the primordial material. So in the first sub-microseconds after the Big Bang, these conditions would be produced. And if we can measure this polarization, maybe we will then understand something much closer to the Big Bang itself. Possible. And astronomers are working on it now.
Спасибо. Вот я все ждала, когда же это появится. Вот оно появилось в интернете. Я имею в виду НЛО. Они к нам пришли. Джон, вопрос про НЛО. Не могу его не задать от имени народа. Замечали ли астрономы неопознанные объекты с крайне странным поведением, которые нельзя объяснить естественными причинами или его естественным происхождением? Я думаю, это, наверное, НЛО. Да? Нет? Ну, если астрономы.
So the question is about UFOs.
Yeah.
We see many wonderful things in the sky that are very far away. And I think our biggest surprise for astronomers in the last few years was about gamma ray bursts. You know, for about 40 years, we knew that there were stars or something exploding and producing immense amounts of gamma radiation. And now we know that these are happening at the edge of the universe. They are stars that explode, and they aim their little jets of material at us. So that's the biggest surprise to me from astronomy. Now, do we see as astronomers any flying objects here in the Earth's atmosphere? No, they don't come to visit me. I'm very sorry they have not visited me. I have not seen them, and I don't know of any astronomers who have seen them.
Ну, вообще, в среднем количество американцев, которые видели неопознанные летающие объекты, неизмеримо больше по сравнению с какой бы то ни было страной. Ну, может быть, это свидетельство богатого воображения. Вот вопрос, спрашивает Алексей Уральцев. Как, на ваш взгляд, что даст больше пользы науке? Ваш новый супертелескоп или большой адронный коллайдер? Если это можно сравнить. Я, конечно, подозреваю, что телескоп.
It's very clear that we see is that no dramatic changes have occurred for science in this country as yet. There are small changes that are occurring, and I think things are going in a better direction. But of course, there cannot be a rain of gold. The money must come from somewhere. So the government receives taxes from the taxpayers, and so it's all up to them what they will do. Right now, everybody is very concerned about the economic crisis, but I think the president is correct that for the long term we must have educated people, otherwise we will not maintain our position as a prosperous country. So I think the president is very correct to focus on education as a very important part of our future, and I think it's obviously true for all nations. So I would like to thank Michael and Yuba especially for arranging all of these events, and I very much enjoyed speaking with you. And so if we have time for just one more question, that would be fine. But anyway, I wanted to make sure to thank you for arranging this. This has been very interesting for me.
Джон, мы как раз вас хотим поблагодарить за вашу лекцию, за то, что вы так долго были с нами, отвечали на наши вопросы, иногда дурацкие, были терпеливые. Спасибо вам большое, не говоря уже о том, что вам пришлось час ждать, поскольку время в Соединенных Штатах не перевели, как во всем остальном в мире. И об этом никто не знал, я открыла страшную тайну. Поэтому и за это вам огромное спасибо, Джон. Информация об этом событии, ответы, ваши ответы на вопросы, которые сегодня прозвучали, появятся в интернете буквально уже в ближайшие 2 дня. Джон, ну а мы будем оставаться на связи. Спасибо, спасибо. Pass my hi to Jane and Susan, okay? Bye-bye.
Thank you.
Thank you. Удачи вам, мистер Кинский. Это значит случай. Все расходятся. Ждет вопросы или хочет что? Вы
сказали, чтобы на связи оставаться.
А телевизор вы смотрите?
Very rarely. I very rarely watch TV.
Но оно очень полезно для здоровья. Лучше... Так, друзья, вопросы, пожалуйста. Еще есть? У нас время заканчивается. Еще буквально 2 вопроса, и эфир у нас прекратится.
Уважаемый профессор Мазер, знаете ли вы русского ученого Циолковского Константина Эдуардовича? Слышали ли вы о циолковских чтениях, которые ежегодно проходят в Калуге, где обсуждаются в том числе философские вопросы освоения космоса, русские космисты? И вот вы упомянули глобальное потепление. Вот как вы думаете, есть ли в этом космическая какая-то причина? Спасибо.
Okay, so there are 2 questions there. I am not aware of Dr. Tsiolkovsky, but it sounds like his work may be very interesting. The possibility of cosmic causes for global climate change certainly exists. We have, of course, only begun to understand the causes of the ice ages and other very large climate changes here on Earth. So there's a lot that we do not know. We are constantly being surprised by the new scientific results in climate change now. Also, it was only quite recently recognized that it is occurring. By the way, it was predicted by Arrhenius in, I think, about 1895, when he was studying the effects of carbon dioxide on the atmosphere, and people did not believe him at the time. But now it's quite well recognized that carbon dioxide and other molecules really do make the Earth get warmer. And he knew in 1895 that the use of fossil fuel would cause a climate change. But it was hard to prove. Now we know from observations that things are changing very quickly, and that it's pretty clear that scientists agree that it's happening mostly because of human activity. But there certainly are chances for cosmic climate causes as well. Just today I was reading a scientific paper about whether passages through different parts of the galaxy could cause climate change here on Earth. The answer that they got was no, it's not possible. But it's certainly an interesting scientific question. Our cosmic environment does change as the sun orbits through the galaxy.
Кто хотел вопрос задать? Ну, давайте последний, потому что я буду завершать. У нас время.
Здравствуйте еще раз, меня Анна зовут. Хотела бы в связи с этим задать вопрос по поводу Киотского протокола, который, насколько я знаю, американцы не подписывают. Что вы думаете по этому поводу? Согласны ли вы с решением вашего президента или кто там, Сената?
I'm not an expert on this subject, so I don't have a careful understanding of it. But it looks to me like Americans now understand much better than they did before that climate change is important and that a world response to climate change must be developed. So something that requires the cooperation of all nations is necessary. So I certainly hope that we will achieve that.
Спасибо. Друзья, мы вынуждены, у нас регламент, осталось буквально 2 минуты для окончания эфира. И я позволю себе, пользуясь правом того, что я сижу у микрофона, задать последний вопрос, который касается организации науки. Джон, весной ваш президент произнес яркую речь о состоянии науки и образования в Соединенных Штатах. И ваш президент обещал резко увеличить финансирование науки в США. Иными словами, господин Обама сделал ставку на науку в разгар кризиса. Вот эта речь у нас в России была переведена полностью, размещена в интернет и средствах массовой информации и вызвала такую оживленную дискуссию в научном сообществе. Вопрос. Вы почувствовали на себе смену этого правительственного курса? Пролился ли золотой дождь на вашу лабораторию?
The answer is hard to tell what will be the most surprising of the results from these great pieces of equipment. I think they work on very different subjects. Both of them are addressing questions of great importance to science, and we certainly hope that they both work beautifully. Wish us all luck.
Очень корректно. Друзья, есть вопросы? Вот да, пожалуйста.
Здравствуйте, Джон. Большое спасибо за вашу лекцию. Меня зовут Роза, у меня есть вопрос. Скажите, пожалуйста, какие научные открытия или научные достижения вы считаете наиболее важными для человечества не из области физики? За последние пару лет.
Пару десятков. Жалко, я его не вижу.
My goodness, well, that's a very large question. I think the parts that intrigue me the most are in biology and in the history of mankind. So there are many discoveries about how human beings came to live here on Earth, and the history of our ancestors in Africa. The ability we now have to do genetic analysis and find out where our ancestors have traveled. I have sent my DNA off to be analyzed, and so I now have a map from the National Geographic in the United States that says my Y chromosome came by way of Kazakhstan to the United States. So and so did most Europeans, I think. So this is perhaps not important, but it is of great interest. But it seems to me the most rapid progress and the things of most great personal importance to people are all coming from biology these days, in terms of scientific discoveries. For engineering, we certainly now also have many wonderful challenges about the future energy supply and climate change of this world. But those are not just science projects; those are also very large engineering projects and social projects. I don't think I answered your question.
Конечно, конечно, Джон, не полностью тема гигантская, но у меня попутный вопрос. А что такого вы о себе не знаете, чтобы вам хотелось узнать? С помощью достижений генетики, биологии. Что вы о себе хотите узнать? Чего вы не знаете?
What would I like to know about myself? Well, I certainly would like to know more about my family history and how people migrated around the world. I think that's it's fun to think about that. It's not actually important, but it's interesting. So it seems to be very popular to trace one's family history as far back as possible. So, for instance, my ancestor was an unmarried woman in England maybe several hundred years ago. It would be nice to know something about the rest of the family and how did that happen. So it's not important, but interesting.
Спасибо. Вопросы из интернета. Анна интересуется. Анна спрашивает: Джон, какую литературу вы читаете в свободное от работы время, если оно у вас есть, разумеется? Жанры, авторы.
Okay, well, the authors that I like tend to be nonfiction authors, writing about world politics and climate change and things of that sort. Mostly I read news material, the Economist magazine I subscribe to, and many other news magazines, and of course professional scientific magazines that I get every week.
Джон, а вы телевизор смотрите?
That I do not read physics, that I do not read fiction material more. Thank you, Michael. It would be a great pleasure when I get to do that in person.
Okay. Bye-bye.
Thank you. And thank your team, KTs and Eileen, which I have had a big letter history.
Yes, thank you.
Thank you so much. Thank you. Bye-bye.